Welcome everyone. We are Team Indiana, and that stands for DUCTI INGENIO, ACCIPIMUS, NATURAM, ASTRORUM. That basically means, like, brought by intelligence, we understand the nature of stars, okay? And let's start with a little of history of the team. It's like, we first start in 2008 with the rover Amalia that you can see there. I don't know if everyone can see, but later you can come near to the board. And yes, this is an old photo. And like, we start as a part of a Team Italia. That was a team composed by various universities in order to participate in the Google Lunar X Prize. That then declinated not so good, but we continued our work on rovers, and like, we are still here. And so this is a little photo of us now. This was a photo in alza il volume. Better? No, cambia niente. Avvicina il microfono. Il bello della diretta. Ok. Okay, so better? Okay. Okay, so this is a photo of us like 1 month ago in Poland. And up to today, we have completed a total of 4 rovers. The first was Amalia, and it was created for the Google Lunar X Prize, and is a small lunar scout equipped with a stereo camera just for mapping and doing photos of the moon soil. And the project was actually space grade, so the rover was costing quite a lot, and there were a lot of like other sponsors, like the Italian Space Agency, Leonardo, and stuff. And it was a good project for the team to start. But after the fail of Google Lunar X Prize competition, because Google like just ceased to like continue the competition, we start developing rover for Martian environment in order to participate to the European Rover Challenge and the Rover Challenge series. So in 2016, we started the Toro project, and this rover was equipped with a 6 degrees of freedom arm that we have mounted there, not his arm, but another 6 degrees of freedom arm. And this rover was then presented in the 2018 European Rover Challenge. After that, like, trying to solve the problem of Toro, mainly for the steering capabilities, we designed Trinity, our second Martian rover. And Trinity had steering wheels and a lot of improvement, but the project was too quick. So, like, just as we came back from Poland that year in 2019, we started thinking about a new version of Trinity, but then the differences were so, like, were that many that we just thought of giving another name. So Ardito was born after the trip. And Ardito improves the Trinity concept, enhancing the locomotion capability, the like manipulation capability with a brand new 6 degrees of freedom arm. And so this project started in 2019, and we are still developing it and like pushing forward the rover. So that's a short recap of our history. So speaking of us, this is a kind of an OBS, organizational breakdown structure, and that just shows how the team is composed internally. So we have a leading board, which is called Imperium, but this is other things, and then a support board, which includes old members of the team and expertise member. And then we have the department, mechanic, computer science, and electronic mainly. And then we have the transversal group that Eduardo will speak a little bit more later. And some other group for helping the team in some tasks, let's say. So the medium design group for of course, graphic and social and video editing, because we have to actually deliver a video for our competitions. The science research group that deals with the scientific task inside the competition that Alessandro will explain a little bit more later, and Alessio again a little bit more. And the management group for like dealing with procurement, keeping track of the work inside the rover, inside the groups, inside the transversal group, and like it's like a glue inside the team, we hope. And now I'll leave the word to Ale, the project manager. I didn't say, but I'm the team leader and system engineer. Okay.
Hi. Okay. So I'm Alessandro Meloni, and I'm the project manager. And I'm going to explain a bit of what we do as our end goal, so like the competitions and events that we take part to. So like first of all, one of the main events we compete are the Rover Challenge series. There are several around the world. With like the University Rover Challenge is in the United States. There are in Canada, in India, in Turkey, some other one I don't remember where, and then the European Rover Challenge that we took part in the last 4 editions. It's held in Poland. Are you hearing me well, or are you like understanding something? I don't know. Now you won't understand me. Now? Ok, let's try. Così? Così non si sente, cioè lo sento che non si sente. Ok, mi sentite? Ok, di certo. I have no idea how to use a mic. Anyway, so these are the competitions. The university competitions, the most tangible events for which we develop our project, like Ardito, Toro, and Trinity, and they all revolve around the same basics, the same basic concepts, like the tasks. The tasks are like a set of functions to perform where you score points, and according to the points, when there's like a ranking, etc. These tasks are based on the modern challenges of space exploration, and so they are like maybe about navigation, like exploring autonomously an environment, maintenance, about like panel and handling objects in general, but also scientific analysis, so exploring, take samples, or also take photos and try to understand the characteristics and the features of the environment, and also like the collection, retrieving, that it's like handling objects and go fetch objects, go and bring them back to the starting point, etc. So like something. They are more or less all based on these same things, with each task having specific requirements in terms of how time do you have, what you have to do, how many things you have to collect, etc., etc. But generally speaking, these are the main focal points, and that are the same, that are parts of the requirements of a robotic space mission of these years, essentially. And these are like a cool night photo from this past September of the European Rover Challenge 2022. And doing like tasks at night, it's very cool for the photos, not so cool engineering speaking, but improvise, adapt, overcome. That's like one of the key things of a student team, especially ours. This is another event we took part last year, and it's like similar to a challenge, but was funded and organized by the European Space Agency. And indeed, it was like a longer concept made to essentially develop a real robotic missions. And the thing was that the requirements asked by this competition, by HISA, were more or less the same of the university competition. So, I mean, the scope, the field of research is that one. Then, of course, something is like a space grade rover, and another thing is a Earth-based, competition-based rover. And in general, we try to be like at the middle, not too easy, not too expensive, to say it. And then, as a team, as a student team of Politecnico, we also take part in several public events with the goal to like promote our activities, but also the university, and more in general, like the engineering part, like to do STEM and stuff like that. And so here there are several events, like also television events, going like, actually this is one like made with children that sometimes come to Polito, and the one in the middle is the ceremony, the degree ceremony of Paolo Nespoli, that you might know is someone that flies above our head sometimes. And then also, as I said, like television events, we went on we were mentioned, and some of us, I think I don't know, some of us were recorded during an event of Super Quark. So, questo video, ok.
Cosa è in pratica un robot di quelli che vediamo nei laboratori di ricerca?
Qui ad esempio i ragazzi imparano a costruire i rover per esplorare gli altri pianeti.
That's all. I mean, it goes a bit around, but there were other things. And then one of the, like this last event, the ISC is one, like the last event we took part as a team, and it's one of the most important space event, as it's like the International Astronautical Congress. So is sort of an expo where all space agency and space companies can present their activities, but also is very important on the field of academic and commercial research, as you can submit and present papers. For example, our team leader presented a paper about additive manufacturing for space applications, and several others, like companies and students and workers presented some papers. So it's a good opportunity also to make networking activity, and it like is part of the will of the team in general to be something a bit more than like a student team, but also to be involved in the research and do something a bit greater than us. We try, at least. But we also succeed sometimes, from time to time. And yeah, so this is like the important event. Like, for example, this event some years ago is the one where Elon Musk announced its mission to go to Mars. So like it's a pretty important thing. And also all of these events are like an opportunity to like do something institutional for like university, but also have fun as a team, because in the end we go there together as a group, and so good stuff. And I think that's it for now about the general presentation of what we do. And now I can leave the stage to more technical people that will discuss about what we do in specific. She's Amalia, he's Lorenzo. and they are the and also Mattia, and they work in the mechanical departments, so mechanics departments. Sorry.
Okay, hi everybody. We are Amalia, Mattia and Lorenzo. Me and Lorenzo will be the mechanical leader for this year. So here you can see our last rover, Ardito. But speaking in general about the department, the mechanical department is one of the most numerous departments in the team and welcomes students mainly coming from aerospace and mechanical engineering. But over the years, even students from civil, geotechnical and biomedical engineering has also been present and active members. So any industrial but even material student interested in robotics are welcome in the department. Okay. So now let's talk about our last project, the rover Ardito. Ardito is a robotic platform designed to be modular so that it can be adapted to various mission scenarios and future application. In this slide, you can see some different mission configuration. On the left, the rover is hosting the UVB payloads for the ESRIC competition. And on the right, we have the deep sampling system for the collection task. The locomotion structure of the rover, you can see here, but even on the slide, consists of a rocker buggy terrain mobility system equipped with 6 independent driven wheels, 4 of which are capable of steering. The wheels, you can see here, are made of spring steel so that they can adapt to irregular terrain. The design follows a custom geometry defined by the utilization of various modeling softwares and adapted to the mission scenarios. The 6 degrees of freedom arm is over there, and it can be extended either in a high position or close to the ground. You can see even the like assembling part here. We have a short video of the arm fully assembled. It can be mainly divided in 2 parts, the structural arm and the wrist. The arm, as you can see in the video, is also equipped with internal ribs connected to the structure with rivets and that prevent deformation and on the weak points. So the end effector that is on the top of the robotic arm is the hand that we use for to execute the maintenance task. Even the end effector is designed to be modular, and because of the difficulty to creating such a performing system, different fingertips were made in order to like accomplish each subtask. So in total, you can see on the right, we have 2 fingertips that were made for the maintenance and for the probing task. So now I leave the microphone to Lorenzo.
So, talking about modularity, as Amalia said, Ardito can be equipped with different systems, such as a deep sampling system, and also the power and avionics module can be changed to let all these payloads fit on the Ardito structure. Here we have the differential system. This is the actual differential, and this is the future, and is placed under the chassis to connect the 2 mobility systems, and it's formed by 4 straight bevel gears and 2 spline shafts. So it let Ardito move. Also, we have during the year a production phase. Where we do these things, the production sheet,
communicate with the companies that will produce our pieces. Another phase is the assembling and testing. Talking about the assembling, every members of the department will work on this part and let the project take life. And in testing, we communicate with people of other departments to test every single components and let it work. This is an advisory, so you can read by yourself. These things are like very sharp. Yeah. So that's it.
Okay. Hello everyone. So now I'm gonna leave you a brief introduce on on our two transversal groups. We have basically two of them: the analysis group and the CAD division. On the CAD division, on the left side, we mainly use SolidWorks as software, and we had to develop all the overall configuration of the team, all the configuration of the rover, and create all the components to give also to the other department a good configuration of everything. And then with the analysis division, we provide dynamic analysis, multi-body analysis using MSc software like ASTRORUM, Apex, and ADAMS. All of them from MSc company, because we really love them. And analysis division have a lot of color, but that's all. And then with the multi-body analysis, we can create okay, this is the video. It's really helpful to us to understand better which is the physical setup, physical environment where the rover acts, and understand better the force, the moments, everything about the physical environment that you have to take in consideration also for the dynamic analysis and other analysis. So, the base of this part is that we have to create components that we can use for the rover. In it, we can start from a concept on SolidWorks, try to get some shape or whatever, and then you have to validate with Apex, and you have to do this with a continuous iteration between with the CAD software and the analysis software, and to create a final model, a final results to give to the production phase and send to the company to produce them. So basically this is a brief introduction, and I'm going to leave the speech to the electronics division.
Can you hear me? Okay. Now we will speak about electronics. I'm Giacomo, the co-leader of the electronical department, and I work on the hardware part of the electronics. One of the biggest parts of our work is the PCB design and production, and this is because almost all the PCBs are made by us. The first part of the PCB production is the hardware design and development. We use software like KiCad in the EasyDA, and probably this year we would like to start using Altium thanks to the student license provided by the Politecnico. These are, for example, two boards, the schematics of two boards that are mounted on the rover. Some PCBs need testing before production. And to do this, we use software like Spice to test them before sending to production. The last part is the effective production and assembly, and we do this in the lab. And is okay. These are other boards that are mounted on the rover, and these ones are, for example, the one mounted on the steering, and the other one is the power control board that controls the power from the battery to the rover. Okay. Another work that we do is the cable management. So this, for example, is the junction box. That is a box full of cable that is mounted on the rover and give modularity because it's full of connectors that can be connected. And so we can detach all the electronics from the rover. Now I will give space to Nicola that will speak about firmware.
Hello everyone, I'm Nicola. I'm the co-lead of electronics and I work on the firmware. Okay. The firmware department deals with writing the code for various ARM microcontrollers, either bare metal or using real-time operating systems. Right now we are working mainly on STM boards, so from ST Microelectronics, and the two boards we have on Ardito are based on H7s and F4s. And for the coding part, we use mainly Visual Studio Code and the tools provided by ST to generate the board support packages. From firmware, we also deal with the communication between the boards. Mainly, at the moment we're using the Ethernet and the lightweight IP to communicate between the high level and the low level, so the main onboard computer and the various control units, so the one for the power, the mobility, and the ARM. And inside the subsystem we use the CAN, so the CAN bus, and also communication methods like I2C, UART, or SPI for the boards. For the next year, given the non-predictability of the lightweight IP, we would like to accomplish a more challenging task, and so we want to complete a new communication system to have a backup in case we have problems with Wi-Fi. So this communication will be custom made, and there's a schematic of what we would like to do. So a transceiver on the base station side, so from where we communicate with the rover, and one on the rover side. With both of them should have F4s or H7 microcontrollers, which communicate with a transceiver, an RF transceiver that sends the messages. So this is the basic idea, so using components that are already on the market, but we would like to bring this even on a higher level, so design our own, make our own designs and implement them on FPGAs. For what we have to do in the next year, next months, from the hardware side, is design new versions of the current boards, and mainly develop the PDU that's currently not really working, and testing. On the firmware side, rewrite the code for the steppers, all the steppers to make them more smoother. Improve the code, all the firmware that's based on real-time operating systems to standardize them, and maybe switch to an operating system that gives us a standard, so a real standard from the IEEE like RTEMS, and switch from the CAN bus to the time-triggered CAN bus. And from cable and harness, it's just rewiring everything again. Now I give the word to the computer science department, so Thomas.
Hi. Can you hear me? Okay. So hi, I am Thomas Gagliano. I am the leader of the computer science department, and I will present to you what we do here. So mostly, if you enter in our department, you can expect to become this. So yes, seriously, what we do here in our department is we try to make our rover as autonomous as possible. To do this, we work in the general project, in a general project called Diana Software, okay, which is let's say a big collection of independent software modules that revolve around the rover. Okay, so software that goes on the rover, software that goes on the computer that controls the rover, and also software that works really near to the firmware, okay, which is like the software which is the most, the nearest to the electronic parts, okay. So our project Diana Software goes by versions, okay, and now we are at version number 1, okay, and we work by layers of abstraction. To make this clear on how this works, I will make to you an example. So let's take, for example, the mobility system of the rover, okay. 2 years ago, what we had as Diana Software made the rover capable to be driven in what we call velocity control. Okay, so we gave to the rover a velocity and an angle, and we were so able to control the rover in the same way as you would control a car, okay, by using a virtual joystick. Then, and this one, Diana Software 0, okay, version 0. Now with Diana Software 1, which we developed last year, the rover is also able to, it's able to be driven like it was before, but also it has a new layer of abstraction, which is what we call a position controller, okay? So the idea is that we give to the rover a point in x, y, for example, and the rover will automatically use these angles and this velocity, automatically generating them to reach that point. Okay, what will happen this year is that we are working in the direction of being able to give to the rover a set of points, okay, and having automatically use the position controller to reach them. And maybe in the far future, the idea is having... To say fly. See. Yeah, to say, no, not only to have him fly, but also to have him calculate and generate the points it has to reach to join an objective, okay, a target point. So to do this, obviously, we need a lot of interface and a lot of infrastructure, okay? So our department is divided, I would say, in 3 main areas, okay, which you don't have to see them like different groups inside the department, but we have groups that work more focused on one area or groups that work more focused on the other. So if you enter in our team, if you join us, you will be able to join and to focus more on what you find more interesting, obviously. So the first one is what we call general computer science, okay, which is the area that develops the code inside the rover. Okay, to do this, we use C++, we compile with CMake, etc. And yeah, so working on this area, you have the possibility to learn a little bit more about software engineering, applied software engineering, which is different, a little different from what we learned here in the Politecnico sometime. And to be like to write and develop code that is near to the operating system, we have Linux inside our rover. Okay, we have a modded version of Ubuntu, and so yes. This was the first area. This is just to make an example. This is the computer that we actually have inside the rover. It's a Jetson Xavier, which is, you can see it as a Raspberry Pi on steroids, okay? It's like a Raspberry Pi, but it's developed by NVIDIA. It's really powerful on the CPU, but also on the GPU. And this enables us to be able to do parallel computing, and also maybe in the future to apply inferencing and machine learning, for example. So if you're interested in this field, General CS is the place for you, okay? Then the second area is what we call the ground segment. This area is more focused on the human-machine interface, okay? So how do we interface with the rover? How do we move it? We do this mainly on a web app, okay, which you don't have to see it as like we go and type www.rover.com, but it's a standalone web app that runs on the computer that controls the rover, but also on a tablet or on a smartphone, okay? The people that work more on this area use JavaScript, okay, to develop this web app. We use Vue and the Quasar framework. Also the communication, but this is for all the rover, is based on MQTT, okay? So by joining this area, the experience is more based on web development. Okay, so more on web interfaces, but also in some sense on ergonomy, if we want. Also this year we will start to develop physical controllers to control the web app, and so maybe who will work there will have the possibility also to develop actual hardware controllers in some sense. At least to design it. Okay, so the third area will not be presented by me, but by Lucrezia, so I will pass to her my microphone.
So hi everybody, I am Lucrezia. I am the coordinator of mechatronics part of computer science. So what we do basically is to build controllers, so to make the rover do what we want is to do, like the mobility. You can see here the first controller that we developed. It was called Confusion. And basically we gave it a velocity and an orientation angle, and with a lot of computation that you can see there, the rover has to go where we want him to. And also, as you can see, our work is mainly divided into two parts. So there is the first part, which is the model, okay, that we develop. And then there is the second part, which is more like simulation stuff. And also, the work is divided between the mobility and the arm. So what software do we use? Basically, if you join mechatronics, you have to do a tattoo of MATLAB on your arm, as I have. No, I'm joking. This is not my arm. But yeah, basically we use MATLAB and Simulink to develop models. Coppelia Sim to do simulations, as I will show you, and also ROS, which is Robotic Operating System, which we will use mainly on the remote challenge, is the European rover challenge, but the remote version, and Thomas will talk about it, where we will use this little guy. And yeah, basically these are the kind of software that we use. Here there is a simulation, okay, that I will try to show you. I don't know why it's not working. Ah, okay, okay. Va bene. Wrong button. So here you can see just the mobility on a terrain that we design, and on the right part of the slide you can see the web app of the velocity controller, and yeah, here is spinning and doing some very cool stuff. And here there are like a position and feedback that we are getting from the mobility. Okay. And okay. So here for the arm, same thing. I mean, there is the first we do the simulation using also Coppelia. And using also MQTT, which you can see there. And yeah, the second video is just they were testing joints on the arm. Ah, okay. Here, basically, they are writing what the arm has to do, and then the arm is doing. Okay, so. This was a very important moment of this year, because basically what happens sometimes is that you are not able to test stuff, okay? So it's very difficult and painful. So we were in Poland, okay? And the position controller is actually the controller that we developed this year, like Thomas was saying. So basically we gave the rover target and it has to reach it. And we test the position controller during the competition, I mean the night before. And this was how, we never tested it, obviously, but this was how it went. So yeah, basically the first time tested, the first time it worked. So yeah, okay, so I give you the rest of the presentation to Thomas.
Okay, so very briefly I wanted to add something about this integration phase. Okay, we have another video of one of these events. I cannot, okay. Oh, okay, so this is one other point of view of another use of this position controller.
Vieni, vieni, Enrico, vieni.
And so the cool thing about this is that this was a work of, as I was talking about before, areas. Okay, so there was a lot of work put in this. It maybe doesn't seem like a lot. Okay, it's just a rover moving, but the idea is there to do this. There was the work from mechatronics people who developed a model. General computer science people who developed the infrastructure to take position from the stereo cameras and also handle different autonomy system, and also the work from the people who developed the web app, where we could actually give to the rover the coordinates. Okay, so if you join our department, this you can be part of a piece of something like that, maybe more autonomous. This is a little list of the skill we are looking for. The thing is, knowing how to code, knowing how to develop is important, but it's not everything. Okay, it's surely appreciated, but even if you are not good in writing code, good in developing, but you are passionate about aerospace, about robotics, about computer science in general, don't be scared to apply, since you will be part of a group of people that will teach you how to do stuff. That's it, thanks. Oh, that was not it. No, I just wanted to add a little thing, which is about this little guy, which is called a Leo rover. This one was not made by us, and it will be used in a competition this year, which is called ERC Remote, which is going to be a competition done mainly by the computer science department. The mission will be to develop a completely new, brand new software, okay, using only ROS, test it on this little guy here, and then the aim of the competition will be that software will be deployed inside another of these guys and used. If it works, good. If it doesn't work, bad. So yes, this is it. Thanks. I don't know who's next. Science.
Hello everyone, I'm Alessio Zaino, the coordinator of the science group. The science group is a group of students from very different backgrounds. This year we were a biomedical that became a mechatronic, chemical, 2 physics, and 1 gestionale, management. And our purpose was to create payloads to analyze the soil and determine if there was life or not. And for the competition ERC, we had to develop a theory, a geological theory, to confirm or be not confirmed on the Mars yard. And that's it. The project we are working on are mainly three. The Raman spectrometer, that is little systems that use lasers and a lot of physics and optics to determine the material that is being analyzed, but with a very specific application. We can use this laser to determine if there is life or not. This project, this system is still very in its early phase. We have everything bought, but we still have to do all these calculations, these dimensions, angles, etc. So it's very early. Another system we have, it's a bacterial centrifuge. The soil goes there, gets spin very fast, then the bacteria that is separated from the soil gets transferred on a little microscope glass, dyed with a trepan blue, that is a dye for the scope of determine if the bacteria is alive or dead, and seen on a microscope. This system right here, it's in the mid phase. We have a lot done, but everything needs to be more tested and brought together. The last one, it's the IRC scientific task. That was the third one I talked about, because you have to do this map, this geological map. No one of us has a geological background, so we have to learn everything in a week, and go there, take some photos of random object and the yard on his wall, and test a theory we created before. There, this year, we went there, and we had to work during the night. That's what we saw. Nothing. It was rough. We worked with 10 photos like that. So, who are we are looking for? People that don't want to work only on electronics, only on mechanical, only on computer science. People that want to work on a whole system, because everything you see, it's basically electromechanical. You have to code it, etc. And we take from any kind of engineering, as you saw from the list I did at the start. And if anyone has a passion about mass geology, please. And that's it. Who talks about the Mike to Meloni. It's a me, Meloni.
Hi again. So now I'll talk about two groups, two semi-transversal groups that are going to be in the team, and that essentially they support the team's activity in ways that are related to the project, not strictly technical, but somehow, some ways essential to the realization of all the stuff. The first one of them is the management group, and this group is, like I said, semi-transversals because it's made of both people that work specifically for this group, but also people who works in other departments and groups can contribute to it. Essentially, the management groups works on three areas, and it's like managing the reports and the documentation, but also like the platforms. In general, all that the data that it's developed by the team and especially for the competitions has to be prepared and sent to the judges in order to make them understand the state of our project, what we are doing, the reasons behind that, and it's essentially a part of it's a crucial part of a project, and also specifically in the space field. If there are like aerospace engineers, you are going to do a lot of documentations in the future, and so yeah, that's a very important part. Another one, less funny but essential, it's the handling of the bureaucracy for procurement and mission. Meaning, it's simply put, it is like all the bureaucracy that is needed to purchase an object with Polytechnico funds, make reimbursements, and also handle all the missions, as people that goes on a mission have to be under the assurance of the Polytechnico and can be involved with reimbursements. That, for example, right now I'm checking the reimbursements for the Polonia for the ERC 2022 event, and that's like another part. As you can see, like yes, bureaucracy, because it's always like it can always amaze you in ways that you never imagined, and and another part, a bit more like interesting but not less challenging, is the contribution to the schedule and budget control of the project. Because you can imagine there are involved like money and purchases, and also like times and phases, and there are dependencies between the several tasks and the several departments. And so the management group, what it does together with the leading board, is essentially to help the leading board is managing these aspects and try to make sure that things are done in the right order at the right times. Then not always happens, but I mean the goal is to make a plan and try as hard as we can to follow it, and at least to know why we are not following it. And to do this, we use essentially most than others two softwares, two platforms. One is ClickUp, that is a task tracking software, and we use we have all the tasks, we assign them, we change their status as they move on and they mature, etc. I mean, it tracks all the activities. And then we have Valley Space that we essentially use it for requirements management, because requirements management is a big part of the documentation and reports I talked before. And then right in the middle, there's like an Easter egg for you that is the ECSS. It's a thing that if you want, you can look into it and then write it in the form. If you already know it, I'm sorry for you. And that's the management part. A thing that I can say about this group is that it's not only for management engineering students, as it's very like a transversal group in the terms of transversal and soft skills it requires. So like everyone can contribute to it. Like I for example, I'm an aerospace engineer, so it's not only management. But so that's it. And then the other group is the media and design that helps promoting and taking care of the image of the team for the public. And here again we have 3 main focus areas. One is like making all the media content, like the graphics and roll-ups, shirts, logos, hoodies, etc. The other one is managing the social media, so like planning posts, making posts, stories. And then there's also the team website management that at the moment we are a bit lacking in the website part, but it's like still a task of this group to manage the website and have it like presentable, especially for maybe companies or partners that can engage in relationship with us. And that's it for the groups. And now there's a pretty important new part, and I leave the stage to Edoardo Vacchetto, the guys we all love, and the IT manager for this year.
So, okay, perfect. Hello, I'm Edoardo. I've been the lead of the electronic department for the last 2 years, and from now I will deal with these wonderful things, so assembling and system integration. As the other guys said before, and as you have seen, there are a lot of systems and a lot of stuff that have to be integrated together to have a system that properly works. So this is more or less what we introduced before about transversal group and horizontal work. So yeah, this is a wonderful image about horizontal work. I discovered this horizontal desk. I don't know, it seems very beautiful. And so, to introduce a little what we have to do about integration, here you have the system architecture, a very brief schematic of the system architecture that we use this year. So it's not the new one, but it's the one we used until now. And as you can see, there are a lot of stuff about mechanic, computer science, and electronics that have to work together. So to do that, we said transversal group and horizontal work, because you have to imagine the team as a matrix. We have the column of this matrix that are the department, and the row of the matrix that are the, I don't know, special purpose group, horizontal group, and the transversal group. This group, okay, this is the product tree of our rover, and it's not coherent with the matrix, but in this image, the subsystem are the column, okay? But you have to imagine the subsystem on the row of a matrix. So, for example, to implement the mobility system or the, I don't know, the robotic arm, we need people from all the department. So some people from the, I don't know, the ground segment, so to have the interface to command it, the electronics to make it move, and the mechanics for sure to have the arm, the object that can be controlled. So this structure was introduced last year, and it seems it worked well. So now we have to improve this structure. The work is not carried out in this way from the beginning of the year. We have a specific moment that we call the stable point in the middle of the development phase, where we want to test, I don't know, maybe one feature of a subsystem. So, for example, that the steer system can receive command, for example, or the arm can move joint by joint, for example, and not with the inverse kinematics. During these days, so that are more or less 1 week, 2 weeks, we work for subsystem and not divided in the department to test all of this stuff. Okay? And, no, sorry, I forgot something. As the name I have from now, so assembling, integration and testing, we have to take care also about the interfaces. So the most crucial part, let's say, of the rover. So for example, from mechanics to electronics, so where we can put boards, where we can place cables, connectors, and stuff like that. And also from electronics to the high level, so the computer science. So for example, the electric interfaces we have to use, I don't know, a communication protocol, and also, we hope from this year, a radio frequency link to connect the base station and the rover in case of failure of the main communication system. So this is mainly an integration job, let's say. And I think that's it for all the presentation. So question time, and please give us your hand for the last time.
Okay, so before question time, just one thing. Another thing that we are trying to focus to this year more than in the last years is the whole concept of operation stuff. So like also people that are willing to do that, like maybe from aerospace. I know that some of you deal with system and concept of operation and project from the beginning, and those kind of stuff are needed for the competition and also for the rover itself to work. So that said, our presentation is over, and thank you for coming. And if you have any question, this is the moment. Yeah, yes. Yes, also if you want to come to see the rover. And about recruitment form, this is the QR of the recruitment form on Google. And for computer science guy, there's like, but it's written in the form, there's a problem with the GitHub repo, so I think that their test will be available this night at midnight or tomorrow morning at 8. Tomorrow morning at 8, okay. But the form is the same, and you can like, since it is on Google, you have to log in using Google, so it saves your answer, and so you can like submit and then modify until like 1 week from now. So next Tuesday, which is the 18th. 18th, okay. And the recruitment form link will be also on Instagram, on our bio, on Facebook maybe, on the website, on LinkedIn probably. So like if you like lose the link, you can like take it later. And yes, question time. If you any of you have questions. I've seen a hand before, but I don't want to take you in. Okay.
We are removing the clothes of our video, so if someone wants to see inside.
Yes. Okay. So thank you for coming.
Thank you.
Oh, I didn't know what's going on. You did way more than us, which is with ERC. It's really cool.
No, we don't do just ERC. That's just
Yeah, no, you do more than us.
Come cazzo si spegne sta roba? Togli le pile. Sì, come?